Hello, can
Yes,
you hear
ma'am.
me
Yes.
now?
Yeah, now,
There
now
is no
also.
echo, correct? Sorry
Yeah.
for that, this thing. I think the sharing is happening as you can see the thing.
Yes, I can.
Okay, Code
Yeah.
Composer Studio.
Yes.
So to start with the thing, what I'll do is, how many of you have tried this?
Ma'am, I tried, but I have not actual
Uh,
hardware.
Okay. So now what I have done is I've connected the hardware. So actually what happened was it was in the debug mode. So I thought I'll come back. Basically, when you open it, okay, you want me to start from scratch or is it okay? I've opened already Code Composer Studio.
It's okay. That is
It's
okay.
okay. Fine. So what you can see is just I have put it as FIR1 in this case, okay? So you will be seeing that defaulted when you create a project, I think I'll start from the thing so that you will know the thing. I'll create a new file, new CCS project, I can call it. So here you have to select which one you are going to use it. In this case, what I'm using is LCDK 6748. And then here it is going to be 674x floating point DXP. And in that LCDK 6748. And for this, the
Ma'am,
version.
you are showing something, ma'am, because I'm not only
Oh,
this
okay.
screen
It's
is
not
stuck.
getting. Sorry. I think sharing is real.
You
It
can
is.
see.
No.
Please share complete
It is.
desktop. Then it will show.
It is sharing. It's no. It's not coming. We'll share entire because it's only going with the thing. Oh, 1 second. I'll share here the entire thing. I think so. Then it will be okay. No, only whenever we are doing demo from there. Stop sharing and I'll share complete thing. Otherwise, it won't come. 1 second. We'll do from the scratch. Mm. Take the screen. Before don't give it because we have when you are changing it won't come. Enter screen.
Are you able to see madam's screen?
I'm sharing now entire screen. Okay.
Yes. Now.
Okay. Now it should be okay. I think so. What I'm starting is from scratch actually. So I'll create a new CCS project. So here LCDK 6748 is there. If you want to come down to the thing, you can select in the board of what I am using is 6748. So LCDK 6748. Okay. So and then if I want to give the project name because I have already given FIR1, so I'll give it as FIR2 here. And then it can be with empty with main.c or empty project, I can create the thing. So because I'll be copying from the other place my okay. I can one more thing. What I was talking is there are compiler version, later versions are there 8.3.5, and then higher versions have come. But this board and then the code composers for 5 also it will be 7.4.24. What has to be selected? Otherwise, it will not be running on the thing. So I can create an empty project and then finish it. Okay, so you will see here FIR2 got created. So if I click on it, these are the default, the command files, whatever memory map for this project, what it will be looking into the thing. So which are the memory that there are DDR2 and then how it is getting allocated, what you can see in the thing. So, and then where your text file and then stack is where you do call operations, or it will be getting push and pop. There is, as I said in architecture, there are no push and pop. So here it takes one of the register and then it pushes the thing into the stack, and then your BSS and then IO operations where it is going to be, and then where the constant store, and then where your data getting loaded, and then system file, and then dot for will be your for what we call it as a heap, basically what it is going to happen. So this is how all the what we call it as where the in the hardware, the memory where it is going to be stored. Okay. So what I'm going to do is I can do push this. I'm creating one sine wave dot C. Okay. I'll copy it. I can copy and then paste it here. I was testing on the thing. I can paste it. So once I do this sine wave dot C, I can do compilation. You will see that project, it is in the compiler basically. So if there are any errors which will be coming out on this. Fine. Library files get linked in this.
Ma'am, you
Pardon?
are also recording this thing because might be for later for reference.
It will be available on YouTube.
Okay, okay. Thank you.
Okay. So you have any error, you will be seeing the thing here. Okay. Compiler error and other things. So now if I go for debugging, so you'll get an error. You can see the thing, why the error will come. So you can see device debugging is happening. Okay. In this case, what has happened is I have, I think I'll go back to the, this is the target CCXML file because I've already created for this. It has taken that as a initial thing. Otherwise, it will ask you how I'm going to do the debugging. So here, what we have is a debugger is the XDS110 USB debug probe, which is connected. And then the board which I'm connecting is which I have to select the thing, which is going to be LCDK6748. So once this is selected, then automatically it will debug and then go into the, the program gets loaded, as you can see here, is Texas Instruments, and then a main where it is pointing to. So debugger and other things initial, and then you can see the this thing debugger pointer is in the start of it. So now what I can do is I can do the run command, what I can give it. And then you have seen that it has run the code, and then it is in the exit.c basically. Right. So now to view this, what we are going to get it, what I'm going to do is, because I need a display part of it, what I can do is I can put a the breakpoint here. You can see I double clicked on this line, so breakpoint has been created. So what I can do is again rerun the code. Sorry, I may have to. It will try to. You will see the problem with that because exit.c it is going somewhere else. Okay. So now what I have to do is I may have to stop this debugger because it is continuously running the thing. So now what I can do is either I can load the program. It is in the run. I can load the program and run it, or I can do the debug also, one of the thing. So some of the icons you will be seeing it here. This is a debugger. Usually we'll not go into the navigation tools and then do it. We use the thing. So if I do it again, it debugs and then runs. It is going to be faster. If it is first time, it is going to take little time actually. Now you will be seeing that it is coming out faster. Since I have put the probe this thing breakpoint here, you will see that this runs and then stops here. Now for going to the, I can see the memory. I can look at the memory map or save if from the memory if you want to save it, or if you want to load some data in from the memory to the program, you can use those things. So for the time being, what we'll do is we'll go to the graph part of it, because I'm running okay, sorry, the maximization of the graph thing is not happening. Sorry, this is not happening. Anyway, so you can see that acquisition, if it is 50 samples or how many samples you want to acquire, you can put the thing. This one, here you can get, I think it is 16, even I forgot what it is declared. It is int is there. So I can go to 32-bit signed integer and then start. Sampling rate and other things, what you can look at it. But only what I have to put the thing is here it is buffer, what I'll be looking into the thing. Sorry, this Code Composer Studio is a little different. I think small is the buffer. Let us check the thing. Second, sorry about the thing. I did not check the. Okay, this is a G buffer is the thing. So I was giving a wrong. You can copy it. It is 128 is the display part of it. So we can. So you can see the sine wave. I think I can maximize this. So you can see that sine wave has got generated. Okay. So have you done the a little bit how to generate sine wave using IAR filter? Have you gone through with it?
Yes, I've gone through.
You have gone through the thing. So you can see the code actually. I'll just explain the code. I'll do the minimization of it. I'm not getting back my CCS 1 second. Sorry about it. 1 second. I may have to restart the thing. I close the. So you'll be seeing from anyway, you have to give from where you will be running your this thing, Code Composer Studio, and then you have to start. If the workspace is created already, it will ask for the workspace also. So now. So you can see that the code, okay, what it is sine, what is the hertz you want to create it. So depending on it, the values, what you will be selecting it. So you will be seeing that F tone divided by F sampling rate into 360 degrees is for Y1 value, what you will be giving it. So in this case, it has taken 3.75. Calculation of 500 hertz is the frequency what you have selected. And then the sampling rate is 48 kilohertz. And based on this computation, you will be getting sine of 3.75. So which is equivalent to Y1 value, what you will be creating it. And then you have to give one of the component AA, that is amplitude. So you will be selecting 2 times the cos of 3.75. So this is the floating, that is Y of 3, what you will be selecting, 0, Y1 and 0. And then your amplitude is AA, what you have selected. And then you will be seeing your IR filter, how it will be calculated going through. So that is Y0 is the current sample, which is Y1 star A minus Y of 2. Okay, this is the equation what you will be using it. And Y2 and Y1, so you will be seeing that all of them are assigned to Y0. Y1 is assigned to Y0, and then Y2 is assigned to Y1. So Y0 is what you will be appending. So to scale full 16-bit range, okay. So it is getting multiplied by 32,000 basically, because it is int. 32768 is using a number or what you will be using it. Right? So then you will be returning your short Y of 0. Then you are putting it on the buffer. So you will be generating till the length of it. So you'll be getting buffer of I will be sine generation. You are calling the function. So sine generation function, you will be seeing that this is your sine generation function, what it is running, okay? So which is going to be, values are going to be returned to the thing. Buffer of I will be holding it. And then you will be calculating your G buffer, whatever the size of it. Buffer size, fill the buffer with data. This is the main function. From here, you will be calling your block sign calculation. From this is your block sign, and then from there it will be internally it is calling the sign generation function. So this function, there are 2 functions which are getting called indirectly from your main function. So from here you will be generating your sine wave basically. So if you want to see direct sine wave also, you can go and then generate in the MATLAB, and that can be stored in a file, and then you can use as a file. So if you want to change any of these values, okay, so then you have to have this, what is the tonal value you want to have it. If it is 1000 hertz, you can give it and then multiply and then check that value and then give it as a sine value. Otherwise, you can give it as a computation here itself, and then from the main you can pass that value of Y1 also. So you have various way of doing it. Fine. So this is how you'll be using your what I'll say is CCS to generate your program. Any doubt in this? Sorry?
No. So,
No. Yeah.
One thing I want to know, ma'am, like here we are generating like sine wave. This is sine wave, right? So after that we have to put in some filter FIR. After that we will do the FIR filter project, right? Okay.
Correct. So
Yeah.
one more thing, what you can do is you can keep this as a base. And then now we'll see convolution. Okay, if you want to see that how I'll be changing it. This is a command file already I told you. So this is one thing, sorry about the thing, because my mobile is also connected. So you'll be seeing other things. So we'll be canceling it out. So what I can do is I can remove this file, delete it, and then I can add any C file here. Okay. So what I'll do is I'll right click on it, add a file. Same thing, what you can do it in your simulator also. So there is see, I can add if you want a seek. Oh, sorry, 1 second. I think before going into the thing, I'll use and I can make this as now active. Okay, so FIR2 is gone. FIR1 is my active. What I'll show you is because sine wave, whether I have got 500 hertz, what I have to check it. How I can check that? It has created 500 hertz sine wave. Can you tell me? What is the way of checking it?
Like this is correctly generated or not?
I showed you sine wave created one. Whether it is created at 500 hertz or not, how I am going to check it? You have gone through the course. That's why I'm asking you.
So in graph,
there is a hint also here.
In graph, we can check. I mean, so if frequency domain also we can check one tone at that frequency.
Do the FFT magnitude.
Yes.
Okay. Acquisition, I can give it as 128 because it has generated 128 samples, 32-bit signed, and then here I'll give it as G. Sorry, G buffer, and then what is it I want? FFT order 5, whether I want it or other thing, what I can select it. So I can go with 5 itself. You can see the thing, how I think I have a problem in coming back. I think I can do the thing. Display property is. I can switch on the grid. Okay. So you'll be seeing that pointer. Okay. So what it is pointing to, the value of peak, what you can see here, what is the value, what it is given. So how do you convert it into frequency now? So I did not do one thing here. One more thing I can do is I can cancel this because properties, whether it will give me the frequency, let me check. Some more, this thing, it gives the thing, some of them doesn't give. It won't allow me to, no, fields, let me check the data fields, what it is, general, okay. What I'll do is I'll stop this one. I think everything is not getting displayed. So, okay, fine. Let it be there. I'll go back to graph again. I'll take it as FFT magnitude. I forgot to, you have the sampling, okay. Sampling frequency, I can give it, one is there. Hopefully it will take as 48,000, what I have to put it. We have done the sampling rate is 48. So here what you have to give is again G buffer. And if I want to increase my FFT order, I can increase it here. I'll make it as 1024 2 power 10. Okay. So it will be 10 is the thing order. Yes. So now you will see that I have given the thing, the value of it. Okay. I can give the, I can move this thing. Peak, what you can see the thing, approximately it is, you can see that it is not exactly 500, it has gone to 796, okay, hertz. So if I want now sampling frequency, I can reduce it. So you'll be seeing this point where it is coming. This point, where is it? Okay, so we can reduce the thing. 1024 what I've taken. So you'll be seeing the maximum peak, and then after that, you'll be seeing that it is dying down and then it is creating it. So you can see the other one, magnitude 0, it will be shown without my sampling frequency given. So what is the thing? So you can see here also, the peak is occurring somewhere here. So this you have to map it 0.03 into whatever your sampling frequency, what you have to map the thing. From here to okay, fine. So this is what I wanted to show the thing, graph basically. So the other way is what I can do is I'll copy a file. You can keep the base as it is, and then, sorry, I should be adding a file here so that you can keep one base and then you can keep working on it. Add a file. So from here, if you have generated your own this thing, this is circular convolution, what you will be seeing it. So linear convolution also. I can add this, copy files. I'll say okay. Okay. I can close this and web.c. So you'll be seeing convolution, circular convolution. So you can enter the length of it. So anyway, I'll run the thing. So I need not have to worry about sorry, I did not close the current debug this thing. So it asked me the thing. So it is pointing to the start of it. As you can see, once I give the debug command, it will be there. I don't want to lose the thing. So what I can do is I can put the breakpoint. Otherwise, what it happens is in the end, you will be seeing that exit will be there. So exit sometimes from the memory, it deviates from it. And the display can close it. I'm not getting the option of closing the display. Let it go. So you can see that. So you can see that because there is a scanf statement, okay. First sequence, what I have to give the value of it. We'll give it as 4. Okay. Second sequence also I'll give it as, I can give it as 5 in this case. Enter the first sequence. What I'll do is usually I give 1, 1, 1 because I know what should be the value of it. And second sequence. So all ones I have given the thing. So you can see that it has not completed. Okay. I'm trying to see where the continue is going to come down. It's not allowing me to continue my debugging. Okay, fine. There is a problem when seeing the printf statement here. Okay, it should have come out, but it is not. Debugger should stop there. So what we can do is output is y is the output. So we'll see that view. We can go to there is some memory error is coming. Let me check the thing.
So memory error means it is
no,
calculated.
memory error is it is pointing here. It should have gone to the start of it. What I'll do is sometimes what happens is you may reset this thing. We can restart the thing here. If it's still, because some of the values will be remaining the memory, I can either restart the Code Composer Studio, or I can reset the memory also. One second, even I'm seeing it where it is there, because different Code Composer Studios give me different way of doing it, or I can do the memory browser. Okay. I have to enter the location here. It is y. What I'm going to put the value. Is it capital Y or small y? 1 second. Small y. Okay. Fine. This is stored in L2 memory and L1D data. Okay. So here I can style what it has stored is 32-bit hex. What I'll take is it is 32-bit int. I can it is int declaration is there, so I can take 32-bit signed int. So the values, as you can see, is zeros. Fine. So because I think I have to go back to my, because I have not
And this computation is happening inside the Code Composer, means in laptop or PC, wherever you were running.
This is running on the board. No, this version of Code Composer Studio, what I have is 9, I think so, which needs a board connection. So if you are doing it in simulator, CCS 5 version is okay, because I have not downloaded 5 on this laptop, what I'm running. Okay. So sorry, I should have given these values first.
Okay, that is good.
That's why the memory is what it is showing is 0. Now we'll see the memory here. You can see the values. Fine. What should be circular convolution?
Yes.
How it is going to work?
And it will rotate after length.
Rotate, okay, because I have given all ones, okay. So all ones means what will be the thing? For the first one, it will do a 0 padding, correct? I have to have, if we are doing it in what I'll say is power of 2, then both have to be padded to 8 is the nearest, because 4 and 5 I have taken the thing. 8 will be the nearest, and then it will be padding 4 zeros to the first data, and then 3 zeros to the next one. Then it will be rotating and adding, and then the output will be 5. So if you can check the thing, it is 4 is the resultant. You can calculate it. This is the y value after circular convolution, what I am supposed to get. Fine. So you can see this way. Our output, if I remove the this thing breakpoint, I think it should rerun actually. Yeah, now I have got the control on the thing. I can completely run and then I can get the, in the console, the values also. Printf statement is there. Otherwise, I can go and check in the memory this way, how the values are done. So the same thing, what I'll do is I'll stop the debugging. I'll remove the linear convolution, same thing what I'll try to run, okay. See, if I come to exit, so you'll be seeing rest of the thing will be, because it is a assembly programming, what it's going to convert it. Same way here, I can remove this and then put the circular convolution. Okay, I can add a file. This way you will be saving time instead of multiple times creating a new project. So what should be the linear convolution output? Can anybody tell me?
So
Anyway, I'll do the debugging. Hopefully my memory, everything will be okay. What will be the output of linear convolution? Here also, y is the output, so I can still keep the thing. Any, this thing guess, you can see while loading it, it has to make all zeros. Okay, y becomes 0. I'll run the code. Is it correct? You have to tell me. Is it correct? I don't know what values it has taken.
1, 1, 4. This
Values
is
have been given here, okay. In this, earlier there we are taking it as the input. Now the sequence has been given, X2 sequence and H sequence has been given here. Okay, this is the input signal samples X2, as you can see here, where my cursor is there. And then this is H2, this thing. So if you want to see those also in memory, you can look at it. So when you do the convolution of the thing, it is 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4.
Yeah.
What should be the first one? What will be the length of it also? You have to tell me.
That length will be 6 plus 4 minus 1, 9 length.
Have you got 9 output? You check the thing.
1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 is there.
Yeah. Okay, it has worked correctly. Now you have to tell me the first value, what it will be.
And so that is there in 1. I can see 1 and second is 4.
Have you done manually?
I'm doing.
We are left with another 15 minutes. Any doubt you have it? Real time, I may not be able to, because my audio gets disconnected if I connect it to the board and then show you that. Okay. No, but mic has to be connected to this output. Okay. Output from here, it should be connected. Sorry, real time, I may not have time to show the thing. In the sense, audio, this is real time, it is running on the board, but same thing can be done using your simulator. Only the audio. Pardon?
Value will be
value,
1.
tell me the thing.
Just a minute. 1, 1, 4, 10, 20, 30, 40, 43, 38, 24.
Correct? You have got the results correctly.
Yes.
The code is running correctly.
Yes.
So you can see that how optimized code, what it has been written. Okay. That is what required. You will see that y of I is nothing but it is getting added with y of I plus xj is the j whatever, there are two loops, okay. One is I is going from 0 to length plus 1 plus length 2 minus 1. That is what you are supposed to get it, 6 and then 4, okay. So it is going to be 10 minus 1, 9. It is variable thing. And then what it takes is I minus j, what it has to do, correct? Multiplication, the previous one. So you will be flipping it. So j becomes k, and then I will be becoming n in this case, I minus j, and then you will be running up to this. Then you are printing. So if you want to see the printing, or you can see it in the memory. Any other thing you want me to show? Anyway, DC.
No,
Yeah.
that is fine. for
DFT and
now.
FFT code is also there. I think it has been shared. Okay, so you can run and then check the thing.
Okay. Ma'am, one thing I want to know, like I am not very good in programming, so like C or C++, so like Python I know, but this higher on this programming I don't know.
Okay,
So
if
that
you're running in Python, okay, so same code can be run. So hardware will not be there in the this thing. Your what is it? You call it the results. You can print it.
is
Only the
generally
thing is deep, you will not be defining it. See, what is the, if you are using FPGA for your design, then you have to select whether you want a fixed point or floating point. Here you will be seeing int means it is 32-bit. So I can give short will be 16-bit. And then if I declare these as character, then it will be 8-bit, okay. I can operate on these various word lengths. So word lengths comes into picture when you are using the hardware in doing it in FPGA or any of the thing. Python and MATLAB, they take default this thing, okay, whatever you need not have to declare them basically. Whatever value you give it, it will be taking it default float or even a long also, it will be long 32 will be 64-bit, okay. So, and then float or double you can work on. So when you are using hardware, these restrictions will be coming into picture. So then you can declare there and then check it. Even MATLAB helps you to run all these codes and then check whether your code is running.
okay.
Okay. There only the problem with the thing is how fast it is going to run. Sorry, I don't have time to show you. This is a C code, okay. So how much time it takes, I can, you will be seeing that some of the, I think it is shared if you are, if you know the thing. Not everything we have used the thing. I have this thing in the tools, you will be, BIOS information also will be, there are gel files also. So here I can, what is it? Handles and other things, what I can give it. So if I want to vary, these are the values what I'm setting it default while loading, okay, before compilation. So when it is running, I want to change the values. I can use the gel file and then I create a handles and then I can vary the values and then in real time what it will be changing it. Okay, that also what you can look at the thing. So there are RTOS also, system on chip analysis also it is going to give. So a lot of functions are there. Everything we may not be able to do it in such short notice. Even the image analyzer is there. So I can connect the camera to this and then I can run as I talked about DCT and everything. So what we have run the thing, okay. So I can display it and then check it. Otherwise, the values, whatever is in the memory, I can load it into my USB stick or something like that. And then I can check it using MATLAB also, display it. So there are various functions. So it is unlimited, only you have to explore them.
Okay.
So even in Python, you can run these codes. Okay, this is just like a C code. So Python code, what you will be writing it there also.
Yeah, sometimes like I use Copilot for means AI chat AI. So they are sometimes they write correct code and means optimized code also. So that we can use, means means if I want to learn
See,
the things.
one of the thing is you have, just like MATLAB, even Python, what you have a built-in functions. As you
Yes.
can see, all these AI tools also, there will be filters used, correct?
Yes.
This is a simpler FIR, IR filters are the simplest one, what we
Yes.
discussed. There will be a lot of adaptive filters and so many things will be coming into picture, okay? So, but they're already pre-compiled and then kept. But when you want to implement on hardware, so those built-in functions, sometimes it may become very long and memory may not be sufficient. Now, even FPGA, if you take a pink board, okay, it supports Python coding. That's why they have named it as pink. Okay. So front end is Python code. So for people like who cannot write assembly code or C code or whatever may be the thing, so you can write in Python and then you can run. The thing is here itself, I think if I go to view, okay, 1 second, whether I have the option of it. This is a C code, okay, common thing. I can mixed thing, what it will be showing me the thing. Okay, here option is not, it is giving. So where it is, I have to check the thing. It will be giving you both the C code, how it gets converted into assembly. This has to convert it into assembly and run. So the length of the code, you can check it, mixed thing will be coming up. If you can check the thing in this, because the Code Composer Studio is a little higher version. So in this, okay, so I can do the disassembly part of it. So you'll see the code, how much length it has gone to in this case. So the same convolution code, whatever this small, I can write it in assembly programming and it is going to be straightforward, and I can say that how many clock cycles it is going to take. Here it is going to be, see, all the assembly thing is there, while loop, everything, how it has created it. And then you can, these are the parallel running architecture, what it is using it, and which are the registers it is using, it will be showing it. So you will be seeing that where the close and other things comes, okay, and then which are the, each one it gets, I think the length of the code goes very high in this. When I see C2 assembly itself, it will be much more, and then Python, it will be still higher, okay. So as you can see that you will be seeing the kernel and everything, it is C code, what usually they run, Linux kernels basically, what they have it. Python is a higher version of it, almost equivalent to MATLAB, I'll say. This is, you can have printf and other things. For that, it will be coming out from the board and then it will be accessing this. So if I remove this printf and then stdio.h, okay, then I can reduce my computation time here also, and then there won't be, it's only for debugging what we'll be using it. Otherwise, in regular thing, embedded C or whatever you see the thing, it is going to be ANSI C, we'll be using it there. I don't have any IO operations being used. Clear screen and other things, those options are not there in ANSI C. For understanding, you can definitely do it. If you want to implement it in hardware, you will have a problem.
Okay.
Anything else? Sorry, we have only 7 minutes to complete.
Okay, ma'am. No, ma'am. That's fine.
Only I've seen one person, so many of them have joined. I don't know, I'm not getting, or others have left. I think it became a, what I'll say it as hard, and then they have left, I think so. Okay.
A little. I'm working in physics research. So
yeah.
here.
So if you have any queries, you can send us the thing in the forum. So definitely
Yes.
I'm answering. Okay.
Okay, ma'am. I will.
Okay, Python, if I have some codes, because I asked one of the student to do it, okay. In the course, actually, I had to search where my codes are there for same thing. real-time signal processing, I asked one of the students to run it. So he did it in the Python also using that, all real-time part of it. So you can look in now. If I get it, I'll definitely, if you're interested, I'll ask them to share it in the forum. Okay.
Okay. Okay.
Any other thing?
No, no.
Okay. Thanks for joining. And then it gave me pleasure to demo the thing. So on the go, I had to do it today. Sorry about
Yeah.
that.
Thank you, ma'am. Thank you. This
Thank
will
you.
help a lot.
Yeah. All the best.
Thank you. Thank you.
Ma'am,
Bye.
Somebody asking something?
Yeah.
ma'am,
Yes. Yes. Tell me.
ma'am, how can we implement differential equations in MATLAB and all?
You have a built-in functions. Okay. In MATLAB. 1 second. If my MATLAB I think still I'm in the sharing. Hopefully my MATLAB will run. Otherwise, I have a problem because my MS Office, whether it will take it or not, it may take time to open MATLAB.
No, like ma'am, like if we want to implement the differential equation in the microprocessor, then like is it
See, one
possible?
thing is, if it is time domain, you may not be able to implement it. So you have to come down to, continuous domain, you may not be able to do it, okay? So it should be a sampled version, what you have to implement it, which you want to use some PID controller and other things for it. You have to approximate them. If you give a help command in the MATLAB, okay, I think, or online you can give the thing. Hopefully it will give me, otherwise online you can test it once. So no,
Okay,
it's not
okay,
showing
ma'am.
the
I will.
differential. So you check in the online, what is the MATLAB command to use the thing. They have different toolboxes, okay.
Okay.
So which toolbox you have to use it, you have to check. This is for which application? Let me know.
I was just trying to do something like trying to graph all the differential equations, and then I wanted to build something from that.
Okay.
So like my first step was to just plot all the differential equations and all. So
Okay. So what degree you are using it?
like currently I'm on second
Okay,
degree
so
only.
second degree, okay, d square by
Yes, ma'am.
dx squared, correct?
Yes, ma'am.
Okay, so if it is continuous, d squared t by d, d squared by whatever your x and then dt squared, you can do it using MATLAB. So you give the help command, it will definitely give you. Okay.
Okay. Okay. Thank you, ma'am.
Commands to use this thing, okay, differential equations. So fine. So what you can do is you can send me the mail. Okay, this is apart from this thing, the course. You send me the mail, I'll definitely reply to that because commands I may not immediately remember. Even I have to go and search and then I can give you the thing.
Okay. Thank you, ma'am.
Yeah. No. Yeah, they'll be giving Rathna is also, it comes in to me. So she's, the email is given there, so you can send me the email, okay? If you give differential equations and MATLAB, it will give you solve differential equation. Both Simulink and then direct MATLAB is also there, as you can see the thing. So there are videos also how to use the differential equations, okay? Can you see it? I'm sharing it.
Yes, ma'am. Yes, ma'am. I can see it.
So tutorials are there. You can go and then run the thing. If there is any this thing, you have the PDF file also. Everything is available. Okay. MATLAB is also available for you till the course end. So you
Yes,
can
ma'am.
use that. Okay.
Okay, thank you, ma'am.
Thank you. Any other question? Otherwise, we'll be closing it. Fine. Can we close?
Yeah, thank you
Yes,
very
ma'am.
much.
Thank you.
Thank you very much, ma'am.
Yeah. All the best.
Thank you.